In our next section, we're going to look at the MPLS Inter-AS Option B exchange, which again is going to be the eBGP VPN v4 session that is going between the edge routers between the autonomous systems. Now, the other example that we looked at previously, which was the back-to-back VRFs or the Inter-AS Option A, there's not a separate section for the documentation that explains this because it's simply configuring the same thing on both ends that you had already done for your regular intra-AS L3VPN. But for options B, C, and carrier supporting carrier, this is documented in the Cisco documentation that you would have access to within the scope of the lab exam. So where we would find this specifically is if we go to the main documentation page, we're going to go down under Products, iOS, under iOS XE, XES, 3S, and then our release will say 3.15. Then down under Config Guides, and under Multi-Protocol Label Switching. Okay, this is going to be under Layer 3 VPNs, Inter-AS, and Carrier Supporting Carrier. And then this would be considered Inter-AS with ASPRs exchanging VPN IPv4 addresses. Okay, the one after that that they're exchanging IPv4 plus BGP, that's going to be for option C. So the key differences are going to be, if we look at this based on the diagram, that when we have our Inter-AS link, which was between router 3 and XR3, in option B, this is a VPN v4 eBGP session. Okay, that's for option B. For option C, this is going to be a BGP plus label session. So it's regular IPv4 unicast BGP, but we're also going to be including an MPLS label with it. Now, in the case of VPN v4, a label is already included with the update anyways, and we don't need any special configuration to allow that. But we'll see that with option C, this is where we introduce the send label command under the BGP process, and then also the address family IPv4 labeled unicast within the scope of iOS XR. So in this case, we're going to look at with some minor changes that I had made between the last example and the current example. And then we're going to do the eBGP pairing between router 3 and XR3. So with the current state of the network, we have VRF A and B that are configured on XR1. Okay, we have eEdge routing that's going to router 8. We have OSPF routing that's going to router 4. We then have a VPN v4 iBGP pairing between XR1 and XR3. Okay, we're also assuming that we're running IGP plus LDP underneath this. Specifically in this case, we were running ISIS routing, and then we're doing LDP for our IGP labeling. But the key point is that we need to make sure that we have a label switch path between the PE routers in order to establish their BGP peering to begin with. So in other words, XR1 can already ping the loopback of XR3. Okay, then we have two different VRFs that are in the other AS. So we have VRF A that's on router 3's link to 7. We have VRF B that goes on 2's link to 10. We then have router 1 configured as our VPN v4 route reflector. So routes are coming in from 10 to 2, 2 sends them to 1, 1 is reflecting them to 3. Okay, then we're going to have our VPN v4 eBGP peering that goes to router 3 and to XR3. This is where we're picking up the example here. So up to this point, all the stuff intra-AS is built. Okay, next let's go over to router 3, and we're going to establish this new BGP peering. So on router 3, let's look at the show IP route connected. And this is going to be on this interface 10.3.13.3 as our local address. So in the global table, let's ping 10.3.13.13. We have reachability to the other end. Okay, next we're going to go under, let's say, show run section router BGP. And we're going to make some changes to, let's see, yes, changes to here, is that we're going to remove this other neighbor that we had previously configured under the VRF. And what's going to change here is that this neighbor now moves to the global table. So under router BGP 123, we have the neighbor that is going to be 10.3.13.13. Their remote AS is 11.12.13. And the address family is going to be VPN v4. Okay, so the neighbor is activated. Okay, then on the other side, on XR3, if we look at the show run router BGP, right now we have just the VPN v4 unicast peering that's going to XR1, which is our route reflector. Now we're going to add the eBGP VPN v4 peering that's going over to router 3. Now, as we saw in our previous example, anytime in XR that we have an eBGP peering, we also need to include the routing policy language that's going to allow the routes out and allow the routes in. So the same case here when we're doing VPN v4 eBGP. So next, let's go to the BGP process. We have VRF, or not under the VRF, we have under just global. The address family VPN v4 unicast is already activated. So we're now going to have the neighbor that is 10.3.13.3. The remote AS is 123, and the address family is VPN v4 unicast. Then we'll say that we have the route policy, pass, goes out, and in. Okay, so nothing really complicated up to this point. We're just adding another BGP peering. Okay, next let's see if they negotiated the address family. So we're going to show BGP, VPN v4 unicast summary. And we should see that we're in the process of forming the peering to router 3. Okay, now the peer is up. Okay, next let's go over to router 3. And notice this log message that was generated. It says, the MPLS BGP forwarding command has been configured on interface gig1.313. Now, they don't really tell you why that you need this, but there's a real important point here. What this changes is that we're forming a labeled session to the neighbor on the other end of the link. So what I mean by this is that if we look at the show run interface gig1.313, this is the link that we're doing the BGP peering over, and we have empty this BGP forwarding command. If we now look at the show IP route, and we look at just our connected interfaces, what iOS is doing here automatically is something that XR does not, and it's a very difficult problem to troubleshoot if you did not know that this was a problem to begin with. Now, remember back when we were talking about the general logic of doing MPLS switching, and when you're forming your BGP VPN v4 iBGP peering session, what I said was that you have to form it to your loopback that is a /32. And the reason why is that there's a software limitation basically in the Ceph implementation that you can only label switch towards a /32 destination. Now in our case here, we're trying to label switch towards the directly connected neighbor. But notice here what iOS did as a workaround for the process is that it installed a directly connected route to the other end of the link. So if we go back to the previous output of the routing table, where I had said show IP route connected, we saw the two /32s for our local interfaces. Okay, these are the addresses that we have directly configured. But on interface gig1.313, we saw previously 2 entries. Now we see 3 entries. We have the subnet, we have our address, and we have a route to the other end, a /32. So this means that if we look at the show IP route for 10.3.13.13, you see kind of an odd output here that basically it's 10.3.13.13 is reachable via 10.3.13.13. It's basically going to the same interface that it's directly connected on. But the key is that if we look at the Ceph entry in show IP Ceph for 10.3.13.13, and let's say detail, what this should show us is that we have an outgoing label of number 26. And if we look at the show MPLS forwarding table, it says that we're going to pop the label as we forward traffic towards this directly connected interface, towards the /32. Okay, and I'm going to come back to this in a minute here. We'll see that why it does this by default and then where specifically this is going to be a problem in the scope of iOS XR. Okay, so next let's look at what's going on in the control plane. So we have this BGP peering that got established between router 3 and XR3. If we look at the show BGP, VPN v4, unicast all summary, we can see on router 3 we have these two different peers. Okay, we have one that's going to router 1, but we're not learning anything. Okay, likewise, we're not learning anything from 13. So let's look at how should the routes be currently advertised. So on the bottom here in AS123, we have the session that's going from router 2 over to router 1. So the route should be coming in as EIGRP in this case, and then we're doing redistribution of EIGRP into BGP. It should be going over to router 1 as a BGP VPN v4 update. Okay, so let's go to router 1. Let's look at the show BGP, VPN v4, unicast all. Okay, we're getting the route in. Coming from router 2, it's 10.10.10.10 as the prefix. Now, router 1 in this case, we have it configured as a route reflector. So without looking at any of the other attributes of the route, okay, so assuming we have a route to the next hop. Assuming we have a route to the next hop, we should then reflect it to the neighbor, but we should leave the rest of the attributes alone. And the key attribute that we're leaving alone is what the next hop value is. Because remember, that's going to be the endpoint of the MPLS tunnel. So from router 1, if we look at the show BGP, VPN v4, unicast all neighbors, 3333, advertised routes, we can see that we are reflecting these routes onto router 3. But from router 3's point of view, it says we're receiving nothing. Or if we show BGP, VPN v4, unicast all, we see basically our locally redistributed routes, but we don't see the ones that were coming in for VRFB. Now this goes back to some of the basic BGP behavior that we previously talked about in VPN v4 peering that works differently from IPv4 unicast. And the logic here is that when I reflect a route to you, or when I send a route to you in VPN v4, you don't want to keep that on the table unless you have a customer that's actually going to need it. And the way that BGP implements this is by looking at the route target value. So we had seen in some previous examples that if you misconfigure the target or you forget to configure the target, the end result is that you filter the routes out. So on router 3, if we look at the debug BGP VPN v4 unicast updates, and then we clear BGP VPN v4 unicast star in, we should see the update coming in from router 1, but then it says I'm denying it because the extended community is not supported. Okay, 10.10.10.10, this is the one we're specifically looking for. And what it really means here is that I'm not importing the route target. Now in this case, we don't want to import the route target though, because we don't have a routing table locally that we want to install the entry on. In other words, we don't want to insert the route into the fib, we just want to advertise it to BGP. Then when the data plane traffic comes in, we're going to use a label number in order to simply switch the packets between the interfaces. But by default, this is one of the potential problems that you can run into with option B, is that if the ASBR does not have the VRF configured, then it's going to filter the routes out. So we have basically one of three options in order to fix this problem. Either configure the VRF, so we configure like a loopback in the VRF and we import the routes, we export the routes. That should allow us to hold them locally in the table. Okay, then we can use them as BGP best routes, we can advertise them on. Second option is to be a VPN v4 route reflector. Because like in router 1's case here, even though it doesn't have the VRF configured, when the routes get advertised from 2 to 1, 1 keeps them and reflects them on because it doesn't know what routes the clients want. It assumes that I have to give them everything and then they'll figure it out on their end by doing the inbound filter. Then last but not least, third option is simply to turn the filter off. So on router 3, if we were to go to router BGP and say no BGP default route target filter. This says as the routes come in, just ignore the target. That as long as you know how to reach the next hop value, then you'll be able to receive the update in. So now let's say clear BGP, VPN v4, unicast star in. We should see that 10.10.10.10 it says I'm now sending an update and I'm going to send it out towards 13. Okay, I'm setting the next hop to myself. Because the route came from an iBGP neighbor, we're sending it to an eBGP neighbor. We set the next hop to whatever our local peering address is. So now from router 3's point of view, if we look at the show BGP, VPN v4, unicast all, we should now be receiving the routes in from router 2, and we should be advertising them out to the other end. So if we look at the show BGP, VPN v4, unicast all neighbor 10.3.13.13 advertised routes, we should see that we're now advertising them to the eBGP neighbor. Now from XR3's point of view, it's going to run into the same problem though, because it doesn't have the VRF configured locally, it's not a route reflector, and we haven't disabled the default filtering. So again, any of those three options are going to be valid, but typically in a real deployment case with this, you would just turn the filter off. Because you don't want to configure the VRF if you don't have an interface to actually forward the traffic, because you're eating up additional memory globally and at the line card level that you're not going to need to use. So if we were to go to XR3 and likewise look at the show BGP, VPN v4 unicast summary, still says we're receiving 0 routes in from router 3. Now if we were to go under BGP, let's say show run router BGP, and let's say that we're going to do VPN v4 route reflection to 11. So let's go into router BGP 111213. This neighbor, this address family, and we'll say route reflector client. Commit to change, and then look at the show BGP, VPN v4 unicast summary. Okay, now we can see that we are receiving the routes in from router 3, because again, a route reflector has to ignore the filtering logic, that it doesn't know whether the client actually needs this route or not, so we're going to accept everything in and then reflect it. Okay, the end result is if we look at the show BGP, VPN v4 unicast, we should see that we're receiving 10.10.10.10. We reflect this over towards XR1. On XR1, if we show BGP, VPN v4 unicast, we are getting 10.10.10.10. And then we have locally here 8888. Okay, that's where we're ultimately going to test reachability between. Okay, so if we now go to router 8, let's look at, does it have this route? So show IP route, EdgeRP. Okay, right now it's not actually learning anything. So let's now look at XR1 and see, did we import it into the routing table? So on XR1, let's look at the show BGP VPN v4 unicast. The route distinguisher is 2:2. Okay, 2:2 for that route. And the prefix is 10.10.10.10/32. Here it says the route is not in a VRF, and there's no best path. Okay, why is there not a best path for the route? Because the next hop isn't accessible, right? So just like in regular BGP rules, when we go from an eBGP neighbor and advertise that to an iBGP neighbor, we're not updating the next hop. And this inter-AS link between router 3 and XR3, it's not advertised into IGP. Now, as we saw in regular BGP rules, we have two ways to fix this. We can either change the next hop to something they do have a route to, or we can advertise the routes so that they do have a route towards that next hop. In this case, the same logic is fine. As long as we have a /32 route to the next hop, then we can use MPLS in order to forward towards that destination. The typical simple solution, though, is to do next hop self. So when we're going from XR3 over to XR1, and when we go from router 3 over to router 1, we would set next hop self to the loopback, because we're assuming these guys already have the route to that anyways. That's where they're establishing the BGP VPN v4 peer, and this is advertised into IGP plus a label. So before we do this, I want to take one step back on XR3, and let's undo our last change. Okay, if we look at the show config, commit, rollback, now show config, commit, changes, last one. Okay, the last one change I made was to make that a route reflector client. So I'm going to undo this. Let's say roll back the config, last one change, and then show run router BGP. Okay, so right now the neighbor's still configured, but they're no longer a route reflector client. If we now look at the routes that we're receiving in, we see that we delete all of the prefixes. Because we're receiving them in, we're not a route reflector, we don't have the VRF configured, and we don't have the route target being used, so the end result is that we discard the prefixes. So again, 3 possible solutions here is just to accept the routes. Configure the VRF and import the target, configure it as a route reflector, or disable the filtering behavior. In the case of iOS 6R, the filtering behavior would be under global BGP, BGP 11, 12, 13, under the address family VPN v4 unicast, and we say we want to retain the route target, and then for what specific routes. Okay, if we say retain route target all, this is the equivalent of the iOS command no BGP default route target filter. That it says, I don't care what the route target is, as long as you have at least one, then I'm going to accept the route in. Okay, the other option is we could say retain route target and then call on RPL, and RPL could say, I want to allow only 10, 10, 10, 10, but not the other prefixes. So then you could match it based on attributes, match it based on the prefix, whatever. Okay, but for simplicity, in this case, we're just going to say all of them, because there's not really a lot of other routes. So let's retain route target all, and then show BGP, VPN v4 unicast. Okay, now we can accept the routes. Okay, the next problem we have is related to the next hop. So again, as I said, there's 2 solutions to this. Change the next hop to so it's something they do have a route to, or give them a route to the next hop. So we could take that connected interface, let's say like on router 3's point of view. So the next hop right now from 1 is this IP. Router 3, when we look at the show IP route connected, or more specifically, show IP route 10, 3, 13, 13. This is a connected prefix that we know as a /32. So we could go under router OSPF1 and say redistribute connected subnets. Okay, before we do this, let's go over to router 1 and look at the show BGP, VPN v4 unicast all. We see that we're learning the routes, but they're not best paths. You can see that there's no greater than sign there. Right now, the next hop is 10, 3, 13, 13. If we show IP route for 10, 3, 13, 13, there's no route to it. So router 3 does a redistribution here of the connected prefixes. Now router 1 should know the route. And if we then show BGP, this should satisfy our condition for the next hop.